Our lesson today is to be able to graph and write exponential functions. We'll start with the definition of an exponential function. Right? An exponential function is a nonlinear function of the form y is equal to a times b to the x, where a does not equal 0, b does not equal 1, and b has to be greater than 0. As the independent variable x changes by a constant amount, the dependent variable y is multiplied by a constant factor, which means consecutive y values form equivalent ratios. If you take a look at these graphs, which graph do you think is exponential and why? Right? Well, if you take a look at them, we know that, this graph here, right, we know that that's linear. Right? Notice the equation. Y is equal to 2x. The largest value of the exponent here of the variable is 1. That's 2 times x to the first power. Here we have y is equal to x squared. And then here, this next one, we have y is equal to 2 times x. All right, notice this function here, right, is not linear, it's curved. All right, and we have this function here, right, is curved. Okay. Here's your exponential function. Does each table represent a linear or an exponential function, and explain why? Well, let's go back to that definition where we looked at the consecutive y values forming a ratio. Well, if I look at example A, I look at my differences here in y, right, from 2 to 4, that's a difference of 2, difference of 2, difference of 2, difference of 1, difference of 1, difference of 1. We know that when the ratio of the change in y to the change in x is constant, which it is here, 2 over 1, we know that this represents a linear function. If I look at example B, the change from 4 to 8 is a difference of 4, or an increase of 4. 8 to 16 is an increase of 8. 16 to 32 is an increase of 16. From 0 to 1 is an increase of 1. 1 to 2 is an increase of 1. 2 to 3 is an increase of 1. Let's talk about the consecutive y values. If I look at the ratio of 8 to 4, right, 8 to 4 is a ratio of 2. If I look at the next two consecutive y values, 16 to 8, 16 to 8 is a ratio of 2. If I look at my next consecutive y values, 32 to 16, 32 to 16, that's a ratio of 2. When your consecutive y values form the same ratio, excuse me, we know that this would represent an exponential function. So this would be exponential, for example, B. Exponential. When we look at example C, or this table here, right, we have difference of 2, 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 difference of 2. Once again, the ratios are constant. The ratio of the change in y to the change in x is constant. 2 over 2, which equals 1. We know that that's linear. We look at example B. From 3 to 1, that's an increase of 2. 3 to 9, increase of 6. 9 to 27, that's an increase of 18. Increase of 1, increase of 1, increase of 1. Once again, we look at the ratios of consecutive y values. So I go from 1 to 3, right? 3 over 1. 3 over 1 is the same as 9 over 3. They're equivalent. 9 over 3 is the same as 27 over 9, right? They're all equivalent to 3 over 1, right? All three of these ratios are equivalent to 3. So when we have the ratio of consecutive y values forming equivalent ratios, that's how we would recognize an exponential function. We continue. So we want to determine whether each table or rule represents a linear or an exponential function. Explain why or why not. All right. So let's look at our first example here. Problem 8. Look at these differences. From 8 to 2, that's a difference of 6. From 8 to 32, that's a difference of 24. And from 32 to 128, that's a difference of 96. If we look at the ratios of consecutive y values, 8 to 2, right, that's equal to 4. We have 32 over 8, right, that's equal to 4. We have 128 over 32, right, that's equal to 4. So we know that this would be, this would be exponential. Exponential. All right, hopefully I spelled that right. We look at example 9. From 6 to 9, that's a difference of 3. Difference of 3, difference of 3. 1, 1, and 1. Right, so we know that the ratio is constant, 3 to 1. Right, so this would be linear. Right. Now let's look at our problems 10 through 13. Right, see if they meet the definition. And remember, the definition we're looking for problems 10 through 13, we have y is equal to a times b to the x, right, where where a doesn't equal 0, b doesn't equal 1, and b is greater than 0. All right, so I take a look at problem 10. Right, we have a b to the x. Right, we have a times b to the x, so that's exponential. Problem 10. Right, we look at problem 11. Problem 11, right, we see there's no, we know that this is linear, right? Y is equal to 12x. We know that that's, y equals mx plus b. So we know that this is linear. And while we're at it, we could say the same for 13. Y equals mx plus b. We know that that's linear. When I look at problem 12, we see that, once again, we want to see if it meets the definition where a doesn't equal 0. Right, here's my a, doesn't equal 0. We have b does not equal 1. Right, b does not equal 1, and b is greater than 0. Right, and that's to the power of x, so we know that that's exponential for problem 12. All right, we're going to skip these two problems because I think you guys, will be able to do those. All right, so we'll skip over those in the video because we've done a few of those. So let's get here. We want to evaluate the function for a given value of x. Right, so now we have to do some math here, all right, using our order of operations. So if we're doing problem A, when we're looking at problem A, we have to replace x with 3. So we would rewrite this as y is equal to negative 2 times 5 to the third power. We have to evaluate 5 to the third power as 5 times 5 times 5, which is 125. So y is going to be equal to the negative 2 times 125. Negative 2 times 125. Y is going to be equal to negative 250. We look at example B. We have to replace x with negative 2. So y is going to be equal to the 3 times 0.5 raised to the negative 2 power. Now, I think this is much easier to evaluate as a fraction. So I'm going to write this as a fraction. So y is going to be equal to 3 times. We know that 0.5 is 1/2, so that's 1/2 to the negative 2 power. Well, what is 1/2 to the negative 2 power? Well, I would flip this, right? 1/2 becomes 2 over 1. The exponent becomes positive. 2 over 1 squared is 4. Right? So this becomes 3 times, right? That's going to become y is equal to 3 times. Um, yeah, y is going to be equal to 3 times, what is that? 4, right? Because that's 1 over 2 to the negative 2, right? That's the same as 2 over 1 squared, and 2 over 1 squared is 4. So that's 3 times the 4, right? So that's going to be 12, which is different than I have in the notes. I see that, but I believe that's correct. Right? So if I take a look at examples A and B here, right, we'll do example A. Example A. This is going to be y is equal to negative 3 times 4 to the second power. We do the exponent first. 4 squared is 16. So y is going to be equal to negative 3 times 16. 16 times 3 is 48. Negative times positive is negative. So y is going to be equal to negative 48. When I look at example B, right, that's going to be, I'll do it up here, I'll need more room. Y is going to be equal to 2 times, I'm going to evaluate the decimal as a fraction. 0.25 is 1 over 4, and that is going to be to the negative 3 power. So that becomes y is equal to 2 times 4 over 1 to the third power. 4 times 4 is 16. 16 times 4 is 64. So that becomes y is equal to 2 times, what is that? 64. So y is going to be equal to 128. All right. Problems 3, 4, and 5. You're asked to evaluate each of those for x is negative 2, x is 0, and x is 1 half. All right, we won't do all of these, but let's do, I don't know, let's do problem 5. We'll do problem 5 together. So we want to first evaluate it for x is equal to, what is that? X is equal to negative 2. So y is going to be equal to negative 3 times 1 over 4 to the negative 2 power. That's going to be y is equal to negative 3 times 4 over 1 squared. Y is equal to negative 3 times 4 squared is 16. So y is going to be equal to negative 48. We want to take that same problem and evaluate it for x is equal to 0. Right? So that's going to be y is equal to negative 3 times 1 over 4 to the power of 0. Anything to the power of 0 is equal to 1. So y is going to be equal to negative 3 times 1. Right? So y is going to be equal to negative 3 when we evaluate that for x is equal to 0. And then we want to evaluate that for x is equal to, what is it, 1 half. So that's going to be y is equal to negative 3 times 1 over 4 to the 1 half power. Y is going to be equal to negative 3 times 1 over, what is that, 1 over 4 to the 1 half power. So we have to do the square root of 1 over 4. So what is the square root of 1 over 4? Well, the square root of 1 is 1. The square root of 4 is 2. So that's going to be 3 times 1 half. So that's going to be equal to, y is going to be equal to negative 3 times 1 over 2. So that's going to be negative 3 over 2. Oops. Erase that. Right, negative 3 times 1 over 2. Right, that's just negative 3 over 2. Negative 3 over 2. All right, for that one. All right. Next page. We want to be able to graph exponential functions when we do that. All right, and using that Desmos calculator, graphing calculator, is going to be really helpful to check your answers. The graph of a function y is equal to a times b to the x is a vertical stretch or shrink by a factor of the absolute value of a of the graph of the parent function y is equal b to the x. where a is less than 0, the graph is also reflected in the x-axis. The y-intercept of the graph of y is equal to a times b to the x is a. We have a new definition, an asymptote. An asymptote is a line that a graph approaches more and more closely. The x-axis is an asymptote of the graph of y is equal to a times b to the x. Right? And if you look at this section here of the graph, notice how the line, right, approaches the x-axis, right? Line approaches the x-axis more and more closely. So that's what we mean by the asymptote. The same thing we would look at this graph here, right? We see once again, right, the blue graph approaches the x-axis, right? The red graph approaches the x-axis, right? So that's what we mean by the asymptote, right? So let's take a look at some of these graphs, all right? So our first example, we want to graph the function, we want to compare, let me get back to a pen, right? We want to compare the graph to the graph of the parent function. We want to identify the y-intercepts and asymptotes of the graphs. We also want to find the domain in the range of f. All right, so let's start with part A. When we want to graph a function, we want to start with some x and y values, right? So I'm going to try to be as neat as I can. We have x values, we have y values. Now, what do we use for our inputs? You want to use inputs that are very, very close to the origin. So we're going to use -3, -2, -1. We'll use 0, and we'll use 1. We'll start with that and see if it gets too large. Right, so now we want to replace x with -3. So what is 2 to the -3? 2 to the -3 is the same as 1 over 2 to the third. Right? 1 over 2 to the third is 1 over 8. 4 times 1 over 8 is going to give you 4 over 8. 4 over 8 simplifies to 1/2. Yes, you are going to have to do all of that math either mentally or write it out on paper. Or use calculator. So, when x is -2, right, we replace x with -2. So we get 2 times -2. Or 2 times, or I'm sorry, 2 to the -2 power. 2 to the -2 power is the same as 1 over 2 squared. 1 over 2 squared is 1 over 4. So we have 4 times 1 over 4, right? 4 times 1 over 4 is 1. Now we have 2 to the -1 power. That's 1 over 2. 4 times 1 over 2 is going to give us 4 over 2, which is 2. 2 to the 0 power is 1. 4 times 1 is 4. And then we have 2 to the first power is 2. 4 times 2 is 8. If we try an input of 2, we start to get too large for the graph here, right? Because an input of 2 would be 2 squared is 4. 4 times 4 is 16. It just gets too large. So we want to stick with, inputs that are, right around the origin. So we go to graph it. -3 and 1/2. Here's -3. And then I go up to 1/2. It's going to be right there. Then we have -2 and 1. Go -2 up to 1. That's right here. Then we have -1 and 2. That's right here. Then we have 0 and 4. Right? That's up here. Then we have 1 and 8. Over 1, up 8. That's going to be right here. Right? And we get this curve. You want to try to draw it as a curve. It's not easy, especially on your computer. Right? But it starts to approach. Right? Starts to approach the x-axis. So we want to identify the y-intercepts. Right? That's the first thing we're asked to do. Identify the y-intercepts. Here's your y-intercept at 0, 4. Right? So that is your y-intercept. 0, 4. Your asymptote. Right? The asymptote, right? It approaches the x-axis here. So your asymptote is x-axis. Then we have, what's next? we have find the domain and range. So we do domain, right? What's the domain? Well, the domain, right, those are your input values. Well, our input values go on forever, right, in that direction, right? I can continue with inputs to the left, and I can also continue with inputs to the right on the x-axis. So the domain is going to be all real numbers. All real numbers. Right? Let's look at our range. When we look at the range here, your range, our graph, never gets to 0. It approaches the x-axis where y would be equal to 0, but it never actually gets to 0. And then it goes up forever, right? Above 0. So your range would be y has to be greater than 0. All right? Let's try example B. We'll do that in a different color. So in example B, I need my x values, and we need our y values. Our inputs we're going to use, we'll try -3 again. -3, -2, -1, 0, and 1 and 2 this time, right? Let's see how far that gets us. Now, 1/2 to the -3. 1/2 to the -3 is the same as 2, 2 over 1 to the third power. 2 over 1 to the third power is 2 times 2 is 4 times 2 is 8, but we want the opposite of that, so that's going to be -8 if we evaluate that correctly. Now, when x is -2, that's going to be 1/2 to the -2 is the same as 2 over 1 squared. 2 over 1 squared is 4. We want the opposite of that, so that's going to be -4. Then we have 1/2 to the -1 is the same as 2 over 1 to the first power. We want the opposite of 2 over 1, so that's -2. Anything to the 0 power is 1, right? But we want the opposite of 1, which would be -1. 1/2 to the first power is going to be 1/2. The opposite of 1/2 is -1/2. And then if we use 2, 1/2 to the second power is going to be 1 over 4, right? Because 1 over 2 times 1 over 2 is 1 over 4. And then we have the opposite of 1 over 4 would be -1 over 4. Right? So let's graph that and see what that looks like. -3, -8, that's going to be down here. -2, -4, that's right here. -1, -2 is here. 0, -1 is here. Then we have 1 and -1/2 is here. 2 and -1/4 is going to be here, right? So our graph is approaching the x-axis, right? So that's our asymptote, the x-axis once again, right? Our y-intercept, we'll start with the y-intercept here. My y-intercept is 0, -1 or -1, right? So that's my y-intercept. Asymptote x-axis, asymptote x-axis, domain. Domain, once again, will be all real numbers because we have x going on forever to the right and x values going on forever to the left. So that's all real numbers. And at a range, we see that because the asymptote is the x-axis, it's approaching y is 0, but it never gets to y is equal to 0, and then it goes down from there. So the range is going to be y has to be less than 0 would be our range. All right. Now, there's just a bunch of problems, right, for you guys to practice here, right? Several problems to do, right? Let me check my time. All right, I want to see how long we've been recording. Wow, we're at 24 minutes. So, you guys can practice those two on your own. But let's get to some funky ones. Where's the funky stuff? Yeah, let's get down here. Right, let's do at least one of these. Okay. So I don't know which one do we want to do. Okay. Well, let's read it before we do it. To graph a function in the form of y is equal to a times b uh, to the x minus h plus k, begin by graphing y is equal to a times b to the x. Then translate the graph horizontally h units and vertically k units. Let me go back to that other problem, right, for a second. You know what I forgot to do? I forgot to compare the graph to the parent function, right? Forgot to do that. So let's look at example A, right? Because we want to compare that graph to the parent function. And let's see what that looks like. Well, when I compare to the parent function is f of x is equal to 2 to the x, 2 to the x. But this 4 causes a vertical stretch. So comparing it to the parent function, we'd have a vertical stretch, S-T-R-E-T-C-H, vertical stretch of the parent function, of the parent function by a factor of 4, by a factor of 4, factor of 4. And then we look at this example here, and we want to compare it to the parent function. Your parent function would be f of x is equal to the 1/2 of x, right? That's your parent function. So how is this different from the parent function? That negative sign, right? And the negative sign causes a reflection in the x-axis. So when we compare that to the parent function, we would say f of, let's see, f of x is equal to negative 1/2 to the x, is a reflection in the x-axis, is a reflection in the x-axis, of the parent function, of the parent function. All right. Now, let's go back to this problem here, because I wish we had time to do all these graphs, and we'll do more of them in class, probably over the course of a couple of days. But which one do we want to pick? Let's do this first one, right? We'll do this first one. So, we have this 0.25 raised to the x power. So remember, I'm going to do that as 1/4. So I'm thinking f of x is equal to 1/4 to the x, and we have to add 3. We still want to make a table of values for x and y, so I'm going to come down here, give myself a little bit more room. All right, so I have a column of x, column for y, and we're going to use -2, -1, 0, 1, and 2. If we replace x with -2, that gives me 1/4 to the -2 is the same as 4/1 squared. 4/1 squared is 4 times 4, which is 16, plus 3, which is 19. Then we do 0.25, or 1/4 to the -1 is the same as 4/1, which is 4. 4 plus 3, 7. 1/4 to the 0 power is 1. 1 plus 3 is 4. 1/4 to the first power is 1/4. 1/4 plus 3, going to be 3 1/4. And then we have 1/4 to the second power is 1/8. Or what is that? No, 1 over 4 to the second power. No, that's not 1 over 8. 1 over 16, because 4 squared is 16. So it's 1 over 16 plus 3. So it's 3 and 1/16. Right, I'm going to graph this. So I have negative 2 comma 19, which, I can't graph that. But that's all the way up here somewhere, right? That's up here. But I can do negative 1 and 7. It's going to be here. I can do 0 and 4. Right? 0 and 4 is going to be here. I can do 1 and 3 and 1/4. 1 and 3 and 1/4 is here. Then I can do 2 and 3 and 1/16. 2 and 3 and 1/16. Right? So it looks like we're going to have a line, right, that goes like this, straight up. Right? We're going to come down, and it is going to approach the line for what? Y is equal to 3. Right? That's what this line is here. Right? Horizontal line that crosses the x-axis at 3. Right? So our asymptote is y is equal to 3. Asymptote would be the line y is equal to 3. And what else are they asking for here? To graph the function, then identify the asymptote, find the domain and range. So the asymptote would be the line y is equal to 3. Your domain is going to be all real numbers, all real numbers, and your range, when we look at our graph, everything is above 3, is above 3. Yeah, everything's above 3 on the y-axis, so the range would be y has to be greater than 3. All right, we're going to stop the video here because that's like 30 minutes, and that's a long time, so hope that's going to be helpful.